So this is the code for processing of the images. It has this class image, which has a constructor that takes path as an input string. It allocates some space to this image buffer. Then it has this member function copy image that creates a new copy of this image with the name copy of the original image. Then it's copy the original image buffer content to this new image buffer. And then it is returning this newly created image. Then it has this image destructor that is deleting this buffer space that we allocated in this constructor. Now we have this process images function that takes a vector of images and does some heavy processing on these images. Now we have this main. In my main function, I'm creating 50 new images, and then I'm calling this copy image function on these images, then pushing these images in my vector, and then calling process images function with this vector. So do you see any error in this code? Yes, we have missed a very important step. So you see, we are allocating space to these new images. We are using these images to create copy of the images. And then we are not using these images once we have created these copies, because these copies are eventually used in our process images function, right? So what about these images? These will remain on our heap. So we need to deallocate this memory. Similarly, for this vector, after processing of the images, we should delete these images as well. So you see, it's an overhead to manually deallocate this memory. And developers very often miss this very important step, which leads to memory leaks. So what's the solution to this problem? So the solution is smart pointer. So what are smart pointers? Smart pointers are classes in C++ that automatically manage memory. These are wrappers around raw pointers that help prevent memory leaks, dangling pointers, and manual memory management. To use smart pointers in your code, you need to include this memory header file, and these follow RAII, that is resource acquisition is initialization. That is the resources like memory, files, logs, etc. These are acquired in a constructor and released in the destructor. So these are the three main types of smart pointers: unique pointer, shared pointer, and weak pointer. We will discuss each in detail. So first is the unique pointer. When you require exclusive ownership, that is, a single owner can be there for a resource, then you use this unique pointer. Since there can be only a single owner, so this unique pointer cannot be copied. They can only be moved. So once the unique pointer goes out of scope or gets deleted, then the resource that it has acquired, that also gets deleted. So when you use unique pointer, when you want single ownership. So this is the code snippet that will help you understand how to use unique pointer. So this is the class unique underscore PTR. We have created a unique pointer of type integer, and this is the resource that it has acquired. Since there can be a single owner, so this operation, that is the copy constructor, we are trying to create another unique pointer using this existing unique pointer. So copy constructor will be evoked. Such operation is not allowed. So if you try to do something like this, it will give you compilation error. So now I have created another unique pointer. Now this is the copy assignment operator. Again, unique pointers cannot be copied. So if you try to do something like this, it should give you compilation error. So this operation, this is allowed. Why? Because when you execute this move, then this UP1, it will release its resource, and this UP3 will point to the same resource. So this operation is allowed because after this operation, only UP3 will point to this resource. So we are still maintaining that there can be a single owner. Now, as you use normal pointers, you can use this dereference operator to get the value. You can say similarly, you can use it on the smart pointers. So when you use this operator, it will print this value too. Next is the shared pointer. So when you require multiple shared owners for the same resource, then you use shared pointers. So how does it maintain how many owners are pointing to the same resource? So internally, this class maintains this reference counting. Once all the shared pointers go out of scope or gets deleted, then the then the resource that it was pointing to, that also gets deleted. So when you use a shared pointer, when multiple part of the code required a shared ownership for a resource. So this is the code that will help you understand the use of shared pointers in C++. So this is the class shared underscore PTR. We have created a shared pointer of type int, and this is the resource that it is pointing to. Now we have created another shared pointer using this existing shared pointer. After this operation, both sp2 and sp1 are pointing to this resource. So copy constructor is executed with this line. Now we have created another shared pointer that is also pointing to this particular resource. Now there are three shared pointer, sp1, sp2 and sp3. All these three are pointing to this particular resource. We can get the value of the resource that it is pointing to using this operator. There is a function useCount in shared pointer class that tells you how many owners are pointing to a particular resource. So if you use useCount function on either sp1 or sp2 or sp3, it will print 3. Now there is a function reset. When you call reset on a shared pointer, it will release the resource that it has acquired. So after this operation, sp2 is no more pointing to this particular resource. So now if you use useCount on sp1, it will print 2. One for sp1 and another for sp3. Now sp3 has also called reset. So after this operation, only sp1 is pointing to this particular resource. So if you use useCount at this point, it will print 1. Now sp1 has also called reset. Notice that this is the last owner for this resource. So when you call this reset on this last owner, then this resource will also get deleted. So the shared pointer will take care of deleting this resource when all the shared pointers that are pointing to this resource either goes out of scope or gets deleted or has called this reset method. So this is the last owner. So after this line, this resource will also get deleted. Now next is the weak pointer. So when you require a non-owing reference to an object managed by shared pointer, then you use weak pointer. So weak pointer can access a particular resource, but they are not contributing to the reference count or object's lifetime. So that is why they are used to break circular references. So to use weak pointers, those must be converted to a shared pointer first, and then you can access the object. So when to use weak pointers? When you want a reference, but you don't want to affect object's lifetime. So this is the code snippet that will help you understand how to use weak pointers in C++. To use weak pointers, first I have created this shared pointer. Now using the shared pointer, I have created this weak pointer. Now this is the class for weak pointer, weak underscore PTR. Now this sp1 is pointing to this resource. This wp is also pointing to this resource, but weak pointers are not contributing to the reference count of the resource. So if you try to use this use count on the shared pointer, it should print 1, because even though this weak pointer is pointing to this resource, it is not contributing to the lifetime of the resource. Now, if you want to use the resource, if you want to access the resource that this weak pointer is pointing to, then you should use this lock method first. So this lock method will return a shared pointer that will point to the same resource that this weak pointer is pointing to. Now, inside this block, if you try this use count, it should print 2. Why? 1 for the sp1, because this sp1 is pointing to this resource, and second for this sp2. Outside this block, since this sp2 is valid only under this block, outside this block, this is no more valid. This has gone out of scope. So now if you try to print this use count on sp1, it should print 1. Now this reset method is called on sp1. Since there is just a single owner at this point for this particular resource, so if you call this reset method on this shared pointer, since it's the last owner, it will delete the resource that it was pointing to. After this point, if you check So this is a method that will tell you whether the resource that this weak pointer was pointing to, if it is still valid or not. So this is the method that you need to call. Since SP1 reset, this was the last shared pointer, and on calling this reset method, this resource has been deleted. So if you call this expired now, then it will return true and this block will be executed. So this was all about smart pointers. You can further explore what other functionalities are provided by these smart pointers in standard template library in C++. In my next video, I'll be implementing these smart pointers from scratch in C++.